find an inverse derivative function value for a square root function. So let's take a look at our first example. Here we're being asked to find the derivative of t inverse of 12, given function t of x is equal to the square root of 10x plus 4, and we're given the point 14, 12. Alright, so we know we're going to have to use the derivative of an inverse theorem here. So let's see, that means we're going to have t inverse prime of y sub 0 is equal to 1 over t prime of x sub 0. So a couple pieces of information we need to identify to get us started. First is we can see that 12 is going to be our y sub 0 value. And moving over to the point, we can see that y sub 0 is also 12 there too. Now, since the y value is 12, that means that our x sub 0 value needs to be 14. So let's go ahead and plug in what we know now. So t inverse prime of, we just found out that y sub 0 is 12. And that is going to equal 1 over t prime of x sub 0, which is 14. And I meant to do that in blue, so let's fix that really quick. 1 over t prime of 14. Alright, so in order to find the derivative of the inverse of 12, all we need to do is find the derivative of 14, or excuse me, the derivative of t when x is 14. So let's start out with our t function. We know t of x is equal to the square root of 10x plus 4. But sadly, we can't take the derivative of a square root. So we're going to have to rewrite it so that it has an exponent. And we can rewrite this as 10x plus 4 raised to the 1/2 power. Now, we'll take the derivative. So t prime of x is going to be equal to, well, 10x plus 4 raised to the 1/2 power is a composite function, which means we need to take the chain rule. Chain rule says take the derivative of the outside function first, so we'll move the 1/2 to the coefficient, we'll leave the inside alone, and then we'll subtract 1 from the old exponent, giving us negative 1/2. And then we're putting the inside back in, and then we need to multiply by the derivative of the inside function, and the derivative of 10x plus 4 is 10. Alright, then we want to simplify this down as much as possible, and we do that by multiplying the 1/2 by the 10, which is going to be equal to 5 times 10x plus 4 to the negative 1/2 power. And when we take derivatives, we can usually leave that in form of a negative 1/2 exponent. However, here, since we want to plug in x equals 14, we actually don't want to have a negative fractional exponent. So quickly, let's rewrite this as being 5 over the quantity 10x plus 4 raised to the 1/2 power. And then we can rewrite this even further to be 5 over the square root of 10x plus 4. And when the expression is in this form, it'll make it much easier to plug in x equals 14. So let's do it. So t prime of 14 is going to be 5 over the square root of 10 times 14 plus 4, which is going to be 5 over the square root of 144. Now let's see, the square root of 144 is 12. So we wind up with t prime of 14 equals 5/12, which now we can plug into our derivative. So we're going to have 1 over t prime of 14, we just found out was 5/12. And we can simplify this fraction by throwing it in the calculator and finding out that the derivative of t inverse at 12 is 12/5. Our next example, we want to find the derivative of f inverse of 4, given f of x is equal to the square root of x and f of 2 equals 4. So this is essentially the same problem, except instead of being given a point, we are given a function value, and we are told that f of 2 equals 4, which is fine. That is enough information for us to solve this problem. So let's start out with our formula. F inverse prime of y sub 0 is equal to 1 over f prime of x sub 0. Now, based on the information we're given, we can now see that y sub 0 is going to be 4. And again, y sub 0 is going to be 4. And that's going to make this 2 inside of the f of x function our x sub 0. So we can go ahead and we can substitute what we know into our formula. We know y sub 0 is going to be 4. And we know that x sub 0 is going to be 2. So, in order to find the derivative of the inverse of 4, all we really need to find is the derivative of f at x equals 2. And we'll work on that on the side here. We know f of x is the square root of x. But unfortunately, we can't take the derivatives of square roots. So we have to rewrite this as x to the 1/2 power, which we can use the power rule to find the derivative. Meaning f prime of x is going to be 1/2 x to the negative 1/2 power. And just like before, we want to get rid of that negative fractional exponent in our derivative because we do want to substitute in a specific x value. So we can rewrite this as 1 over 2x to the positive 1/2 power, or 1 over 2 radical x. And now that it's simplified, we can go ahead and we can substitute in x equals 2. So we're going to have f prime of 2 is equal to 1 over 2 radical 2. And usually we like to get radicals out of the denominators, but we're going to leave it like that for now. And you'll see why I'm going to do that in just a moment. Because now we can plug that into our formula. So we're going to have 1 over, and we just found out that f prime of 2 is 1 over 2 radical 2. And the great thing with a compound fraction, specifically with a fraction in the denominator, there's a shortcut that says we can just take the denominator and multiply it to the top. So that's going to give us 2 radical 2 over 1, or just simplified 2 radical 2. So the reason we left the radical alone over here was because eventually it became the denominator. And therefore we just found out that the derivative of f inverse of 4 is 2 radical 2. And finally, a word problem. Uh-oh. So the function f of x is equal to the square root of x plus x squared plus 1 is 1-to-1 for all x greater than or equal to 0 and has an inverse in that interval. Find the slope of the curve y equals f inverse of x at 3, 1. Now, fortunately, this has all the information we need. It's just told to us in a very different way than we're used to seeing. So first off, it tells us that we want to find the slope of an inverse function. Well, let's remember that slope is another word for derivative. So really, what this question is asking us is to find the slope of the inverse function. So that means we're going to have to use our formula. And let's see, we're going to have f inverse prime of y sub 0 is equal to 1 over f prime of x sub 0. Now we're also told where we want to find the slope of the curve. We want to find the slope of the curve at 3, 1, which makes this 3 our x sub 0 and makes this 1 our y sub 0. So then we can go ahead and substitute these values in. F inverse prime of, we just said y sub 0 is 1. And that's going to equal 1 over f prime of x sub 0, which we just found out was 3. So in order to find the derivative, or to find the slope of the inverse at 1, we just have to figure out what f prime of 3 is. But before we do that, we need to just talk about some of this other stuff that's in our problem that we didn't seem to use. Well, let's think back to the derivative of the inverse function theorem. So basically this guy. In order for us to use this particular function, we need to know that it has an inverse. And that's what the rest of this is telling us. It's telling us that the function is 1-to-1, and we know that 1-to-1 functions have inverses. So it's basically just reaffirming the fact that we can use this formula. So now let's dive in and let's use it. So we know our function f of x is equal to radical x plus x squared plus 1. But since we can't take the derivative of a radical, this is x to the 1/2 plus x squared plus 1. And now we can find the derivative quite easily by just using the power rule. So f prime of x is going to be 1/2 x to the negative 1/2 power plus 2x, because the derivative of 1 is 0. Now, just like the previous examples, we do want to get rid of that negative exponent. So we can rewrite this as being 1 over 2x to the 1/2 power plus 2x, or 1 over 2 radical x plus 2x. Now we can substitute in the x equals 3 term. So we'll have f prime of 3, and that's going to be 1 over 2 radical 3 plus 2 times 3. And we can simplify this a little bit more to be 1 over 2 radical 3 plus 6. So we can substitute that into our formula now. So this is going to be 1 over 1, I wanted to put that in green. Let's try this again. 1 over 2 radical 3 plus 6. And oof, this is not very helpful. So we need to somehow simplify this down. So what I'm going to do first is I'm going to try to combine both the terms in the denominator into one single fraction. So to do that, I'm going to have to rewrite 6 as being 6 over 1. And I'm going to have to multiply that by 2 radical 3 on both the numerator and denominator. So we'll have the same denominator. So let's rewrite this. I'm going to have 1 over 2 radical 3 plus, what's that going to be? 6 times 2 is 12 radical 3 all over 2 radical 3. Well, then I can combine those two fractions together to have 1 over 1 plus 12 radical 3 over 2 radical 3. And then we can use the trick we talked about in the last problem. Since we have a fraction in the denominator, we can take that denominator and just multiply it to the top, giving us a final answer of 2 radical 3 over 1 plus 12 radical 3. And this is the slope of the inverse at the point 3, 1. And all right, folks, that is it. That is finding an inverse derivative function value for a square root function.